Hello, this is Romeo Cat Computers, and today the calculator is finally done. This is my complete and full 8-bit calculator. It can add two 8-bit numbers, an A and a B, and it'll output an 8-bit number plus a 9th bit because of carryout. So I'll give you a tour of the board. This right here is the input board. It's got two inputs, an A and a B. They're both 8-bit words. So you can input two numbers that are up to 255. This button right here, when I push it, enables subtraction. So once I put two numbers in, I can hold it down and it'll give me a minus B. This board right here is the output, and it just expresses the output in 9 LEDs. This is the memory control board. I'll get to that in a second. This is the B-line inverter. Now you'll notice it's a bit bigger from the last video. And if you look behind all these wires, it's actually also the power distribution board. It takes one wire in, which since it's 5 volts, I've hooked up a USB cable, and it's being powered off of my laptop right now. And it just splits it up and gives multiple screw terminals so I can individually power all the boards. These two are my 4-bit adders. I think I talked about them in previous videos. And there's two of them, which makes an 8-bit adder. And this is the primary function of the calculator is for these to do math. And this is the memory board. Now the memory board isn't plugged in right now. You could see it's so advanced it's got not one but two daughter boards. And that's not because it's advanced, but it's because it's been plagued with problems since the beginning. Now the theoretical design of using the D flip-flops in this particular way doesn't have any problems, but for some reason in execution, some things don't quite work. The D flip-flops seem to be working fine, but there seems to be some manufacturing errors in the board. Not from the factory, I mean like my own manufacturing. And there's a bit that gets stuck on, the bits are kind of out of order and weird. This chip fried itself, and this is a new one, which is why I made a daughter board, because I soldered it in and then I couldn't desolder it. So I just had to rip it out and then solder this extra board. This right here is actually removable. And the D flip-flop chips, these two, would normally just go there. And you can put them in there, it won't really make any difference. Originally, I thought the problem might be that I left all the inverted outputs of the D flip-flops floating. So I made this extra board that adds 8 LEDs to each of them. Well, that didn't solve the problem, but it sure as heck looks cool. But that can just plug back in. So I'll show the memory later. But right now I just have it unplugged, because not only does it not work, but it kind of interferes with this board for some reason. Alright, so let's do some math. I'm going to add 75 plus 115. And we should get a result of 190 over here. So this is my A, and so I'm going to put 75 in. So there's my result. And here's my notes to make sure it's right. It should be. Here's another one. I put in 212 plus 88, and the answer should be 300. And I double check this is 300 in binary. So we know the calculator can do addition. What about subtraction? Well, now that I'm holding the buttons down, we can see that it's giving a result of 124, which is correct. 12 minus 88. Yeah, so that's the calculator. Now I'll admit it's not terribly well built in terms of the wiring. You may have seen a few jump cuts in that last segment, and that's because it was being weird. The wires in, particularly the first full adder, they're not exactly touching, but like they were giving weird results, and I kind of pushed them and then they'd give other results. But generally, when it wants to work, it works fine. So right now, I have the memory board plugged in. And I'm not going to move the camera around, but trust me, all the LEDs on the memory board are illuminated. So there's two buttons here. One of them is to save whatever's over here, to basically just flash it. Then the other one's to set it all to zeros. The clear doesn't work. I can't get it to clear all of them, and that might be down to the design of my board, the way I have it. It might just be not how you're supposed to do it. The save feature mostly works. So let me show you. I'm gonna put some numbers in here, just kind of an on-off pattern. Now you can see right off the bat, this bit is on, this third one. It's not supposed to be on. This bit is just stuck. It's a stuck bit. There might be an error in the wiring, although believe me, I've checked and I've looked, I can't figure it out. So that bit's always stuck on, but let's save it. Well, it saved something. Well, first off, this bit is off, it's supposed to be on. This one's on, it's off. This third one is on, but we know it's always stuck on, so it doesn't matter that it's correct. I've kind of, sort of, almost created an inverter, somehow, but then even that's not correct, because these are both off, but these aren't both on. One of them's on, one of them's off. So, it does save stuff. Like, if I change the number here to something else, then and save it, it does save something different. Could also be that I have the wiring out of order. So anyway, I guess that's the calculator. Besides the memory board, which I will improve on in future projects, it works for the most part. So what do I got next after this? Well, this isn't the end of the 74LS calculator series. This is the end of the part where I work on this whole calculator. See, after this I have plans to make something a bit more advanced. I kind of want to sort of make a CPU architecture based on 74LS chips, based on this sort of design. It'll kind of be centered around the idea that you can throw two numbers in and it goes through a full adder, like what's up there, but then you could also tell it to go through other Boolean logic units. Basically, it'll be a big logic unit. You could tell it to do certain things on two different numbers and it'll give you an output. There'll be registers similar to like these memory units, except there will be multiple ones, and of course they should hopefully work. Try to get a hold of some bus transceiver chips that could possibly improve it. But I'm done with this project, and I'm probably going to take a bit of a break. So me working on this future great idea, which I haven't even fully planned out yet, probably won't happen until maybe later next month. I don't know. We'll see. I'll do it one of these days. Anyway, that's going to be it for this video, so I hope you found it interesting, and I'll see you in the next one.